Unless it's chemistry, I'm not gonna. I only know if enough chemistry got me through my physics, which is less than you might think. Um, so whatever you guys want to look at. Yeah.
How do you find the horizontal asymptote function?
Oh, how many situations can you be in for a horizontal asymptote? Three, right? And what do they all kind of relate to? The relationship between what?
Fractions.
Numerator and denominator.
The relationship between numerator and denominator. More specifically, what about the numerator and the denominator? The degrees. I love it. You guys still. I desperately want this to make nothing but the most sense in the world. If the bottom degree is bigger, the number I'm dividing by gets really crazy big. So the whole thing's going to get really crazy small. That's why it makes sense. If the bottom degree is bigger, it's going to have a zero asymptote. Are you guys going to? And then, of course, if the top degree and the bottom degree are the same, right? So let's do a couple of quick examples. There we go. Okay. Maybe. Oh. So many buttons to push. Bam! Okay. Alright. We're all gonna focus in a minute. It's gonna zoom in any moment now. There we go. Okay. So let me ask you, first off, let's say, what's the horizontal asymptote? What situation am I in? The degrees are the same. So they are lockstep with each other. Every step, neither one is growing that much faster than the other one. So they sort of like cancel each other out, and then what would be left? What's the asymptote here? Okay. And be more specific. What do I mean by that? The asymptote is not 1/4. That's not even a point. I know. It's very picky. I'm a math guy. What do you expect from me? Say it again. Sorry, I think I heard. Y equals 1/4. I love it. Gas. Now, just to throw on some more stuff on top of this, because I made this specifically. One mistake that a few people made is one that I try to point out to be careful about. Where do vertical asymptotes come from? Denominator, yeah. Why does that make sense? Because vertical asymptotes are walls that tell me where I can't go. And that sounds like domain. That sounds like inputs I can't use, right? So what would I do to figure out the vertical asymptote for this guy? So, yeah, factor. Yeah, so let's go ahead and factor both of these. It's a good first step. So on the top, what's that?
X minus 3x plus 2.
Got it. And on the bottom, if I take a 4 out, I'll be x squared minus 4, so then that's going to be
X minus 2x plus 2.
kick ass. All right, let me stop for a minute. So if it's not already factored, it's a very good idea to factor it because vertical asymptotes are what x can't be, and I get that from the bottom. I get that from the denominator, right? So what are my vertical asymptotes going to be? Where am I going to put my walls? 2 and -2. So to be more specific, x equals 2, x equals -2. Kind of like an actual negative. There we go. Some people identify these as some of the x-intercepts, but of course that can't be true because x-intercepts are points the function goes through, and I'm not allowed to use 2 or -2 for this function, so it can't go through an input of 2 or -2. What are my x-intercepts? Why is it really easy to see them now?
Because the top
Yeah. So the only way of fraction, so again, x-intercepts are when the output is 0, when y is 0. The only time the output of a fraction can be 0 is if the top is 0. Does that make sense? So then we shortcut it. We look at the top for x-intercepts, I look at the bottom for vertical asymptotes. Because of the idea of where they come from, right? That's just a shortcut. So what are my x-intercepts? Say again, sorry? Where are those at? Where'd you get those from? They're on the what? The top or the bottom? Yeah, so if I put a 2 in there, I'm dividing by 0. Right? I'm not allowed to do that. That's why those are vertical asymptotes in. I'm not allowed to use an input of 2. You guys see that? This idea is almost too silly to believe. I'm not allowed to use 2, so what do? I put a freaking wall there. That's too beautiful to believe that we just do that shit. We just put a wall there. Can't go here. So that's already out of contention to be an intercept, because an intercept's a point that my function must go through, right? You guys understand? So the only way a fraction can be 0 is if the top is 0, and that matches with what my x-intercepts are supposed to do. They're supposed to make the output 0. So what inputs make the output 0?
Negative 3 and 3.
Good. So what are my x-intercepts?
Negative 3 and 3.
No.
No.
3, 0.
All right. You all can moan if you want to. It's okay. But just be specific, right? I'm not going to necessarily take points off, but x-intercepts are points, asymptotes are lines. You guys familiar with me? So if you say the horizontal asymptote is 1/4, I know what you mean. I'm more than likely not going to take points off, but it's y equals 1/4. That's it. What about my y-intercept? Yeah.
Plug in 0.
Huh?
Well, since you plug in 0.
Oh, plug in 0. Yeah. So plug in 0.
Negative 9, negative 16,
So 9/16. The negatives cancel. I like it. Let me stop for a minute. Is everybody with me so far? I need you to see how all of this just kind of flows. This is the first step, is just getting all of this information, and then we use this information to graph this thing. You can always check your work on the calculator. Just understand, if you copy from the calculator, I am going to know. You don't know how to do it well. You don't. I'm going to know. If you make a mistake, again, and I love this, a few of you guys have done this, you made a mistake in the work, the graph looked funky, but you still did it based on your work. Tears, right? Was your graph right? No. Did I give a shit? No. Because the most important thing I'm trying to get from you is, can you identify these things, and then can you translate that into a visual, right? Okay, so I don't care if the visual is not perfect. I don't want it to be perfect. It can't be perfect. We're just human, right? But I want it to show this. I don't know if you guys believe me. Okay. Is that all right? And then you just plot all this stuff out. You wanna graph this thing? Yes. Yeah. Let's graph this real quick first. Take a minute, try to graph this information, and then I'll catch up to you. And while you're doing that, I'll give out more stuff here. And just to remind you guys, I know I keep repeating myself, but you can make corrections to quizzes, you can make corrections to tests, you can get help on those corrections, you can get help from me. If you're tired of listening to me talk, you can get help from tutors. Okay.
We need
About
that's by tomorrow, right?
Whoa, wait. Let's finish this one up. Sorry?
That's by tomorrow.
Yeah, buddy. Yes. Yes.
So
So
we
the
have-
right way to look at that is, I allow you to make corrections.
We have to do homework up to 6.4.
Yes. Hopefully you did a lot of it over the weekend. That's probably the right way to do it. Or you can do it all tonight. It's up to you. Yeah. I understand totally that college is a balancing act that most people don't do well with, me included. So, okay. So let me catch up to you guys. What did you plot first? Huh? Sorry? Intercepts, kick ass, that's a good idea. All of my input stuff, all of my X stuff looks to be contained, so I can make it a nice 1, 2, 3, 4. 1, 2, 3, 4. Right, none of my inputs look to be very large, so I can make a nice scale there. I just don't know what my Y scale is going to be yet, necessarily. So I'm going to plot my intercepts, which were -3, 0, and 3, 0. Y-intercept, I don't know where to put it yet. I haven't picked my Y scale yet. I can put, what else can I put down? Can't do that yet. Don't know what my Y scale is going to be yet.
Vertical asymptote.
Vertical asymptotes. All right, those are my walls. There we go. All right. So now I can get a feel for, I need you to understand my horizontal asymptote is going to be up here somewhere, correct?
Yeah.
So pretty much, do you understand that once I plot that, I know what this is going to look like, I know what that's going to look like? Do I have any information about the middle region? No, not yet. I sort of do. So I need you to see this. There's no way in frickin' hell the middle could look like that or like this. Why?
Because there's no x-intercept.
There's no door through the x-axis there. There's no way. So I know it's going to look like a parabola down or a parabola up. You guys with me? I know it is. And in fact, what's my y-intercept?
9 or 16.
So I know it's going to be parabola going up. Do you guys understand? Do you see what I'm saying? There's no way through the x-axis. So it can't look like this. There's no way for it to go through. Some of you guys make assumptions and then you just kind of like draw and I'm like, no, there's no x-intercept there. You cannot go through the x-axis unless there's an x-intercept there. Yeah.
Also, it was the degree was 2.
No, careful about that.
Oh, yeah, no, wasn't it a 2? Oh, yeah.
Careful about that.
Oh.
It truly, if there was an x-intercept here, this would go through. You can't look at this and say anything because it's not, it's the interaction between these two things. You with me?
Yeah.
Now, to be honest, let me stop for a minute. This is definitely not a parabola, correct? Because it's x squared shit divided by x squared shit. Yes? Parabola is x squared. If I put, I need you to understand this. If I put one more term on the bottom, if I made it 4x squared plus 3x, whatever that's factorable, are you guys with me? It could totally do this in the middle. So it's not parabolic because there's a square there. It's parabolic because there's no x-intercept there. Right? So don't try to make too many generalizations. Rational functions are the interaction between the top and the bottom. Don't try to think ahead about what it's going to look like because then you start to force it to look the way you think it's supposed to. Does everybody understand? I don't have to know this ahead of time, but I know it now. I know this is going to be parabolic because it can't go through the x-axis. So there's no way it could do this or this. It's got to do this or that. And now we know it's going to do this because my y-intercept is positive. Does anybody understand? I don't need any more points. Do you guys kind of with me? Because, so let me make I'm going to make my y-axis scale really, really freaking nice to me. Right, so if you have lined paper, you can make, let's say it's like this. You could be very nice to yourself, right? Because what is my freaking horizontal asymptote?
Not, or like.
1/4. But now that I was nice to myself, I can find 1/4 really easily. Yes? Yes.
I do remember you were saying that the graph can go to the horizontal axis.
Totally.
Just the vertical axis, that's what we.
Yep. So here, I know what this is going to look like. Do you guys see that? That's awesome. And if you wanted to, you could plug in something, but I know it's got to go up against that, and I know it's got to go up against that. Now, in general, could this go through the horizontal? Yes, but then eventually it's got to come to it. And if you don't capture that in your work, I don't want to see it on your graph, right? And this side, same idea. It's got to go up against that. It's got to go up against that. I don't need any more help. That's a good enough. So this is a little better than a rough sketch, but it's still not a perfect sketch, and I don't want perfect. 9/16. Isn't 9/16 just a little more than a half?
Yeah.
8/16. So I'm going to put right there, and I'm going to say it goes like this. How do I know it does like that? Because there's no extension. Now it could do this, or it could do this. I don't want to see that shit on your graph because I didn't do any work that told me that. This is the best I can guess, right? I don't know if are you guys kind of with me? Does everybody really understand why that's a parabola? It was the only reason I knew that was going to be parabolic, because it can't possibly go through the x-axis. So it's got to go that way. It's got to.
And you could even check by plugging in a point.
Totally. You could plug in -1 and 1. This is an example of a problem where you did not need more points, but I'm always going to let you plug in. I'll say like at most something, because I don't want you to just make this long ass list of points and just plot them and then get the shape that way. I want you to figure out the shape, but you could put 1 and -1 and make sure that it's there. Are you guys kind of with me? Maybe. Stay with me. I do want to point out one thing. This kind of goes back to your question, Philip. This is nothing you need to do. I just want to point this out. This specific function, if I put a -x into it, doesn't it become the same as it is now? What do I get when I put a negative into the square? Doesn't that kill the negative? And then here, same idea, correct? So this function is actually symmetric. I'm not going to make you notice that. I'm not going to make you test that. That's just another reason why this has got a parabolic shape, because it's got to be symmetric. But just, I want to show you this. Shit, do I have grades up here? Oh, no, no, good. Real quick. Ba, 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 da, ba. All right, so what if I take the same, what was that, Jeff? I don't know. Or, what was it? I'm sorry. You got it right there, buddy. X squared minus 9. And I'm going to do this. Let's do the function first. Let's do the function first. There it is. Okay, what do you do? Yay! Okay. What if I put in here, what's going to make sense, Jeff? That's a good question. Oh, almost anything. That's true. You put in here plus 3x. Okay. Didn't do what I wanted it to. That's okay, Jeff. Is it symmetric anymore?
Well, yeah.
Is it?
I know, it's just the 3.
It's not symmetric, right? Do you guys agree? I mean, I know what you mean. It's kind of like,
Shift it over to
it's got like a funhouse mirror. You guys see how this is not symmetric? Yes. It's kind of like this. Maybe. Okay. I wanted to be a little more extreme. That's okay, Jeff. There we go. Perfect. Ha. Look at that shit. See?
How did that change?
See?
Why did that change that like that?
Because now when I'm changing the bottom, stay with me. When I just changed the bottom, correct? What does that change? The location of the what? Okay. Coming back to this, this is nothing you have to know. This is just observations. So come back to this. If I push these out far enough, isn't there another x-intercept for the middle to go through? If I took these walls and I pushed them over, and I'm not changing the x-intercepts there, did I? I'm just changing the bottom. Are you guys all with me? This is going a little further than we have to worry about that. If I move this wall over, doesn't that give it another x-intercept to go through? So let me come back to here. Do you see how it went through this x-intercept? Because now it looks like the vertical asymptote is right around almost -4. You guys see that?
Like in between 3.9.
So let me do this. This is kind of nifty. So at some point, it does, watch this. This is so cool. You ready? Watch this. This is almost like two soap bubbles coming together. Sorry. Again, this is nothing. I need you to understand why that's true. The vertical asymptote is on the other side of the intercept. So now there's no x-intercepts in the middle. If I keep pushing that wall over, now I bring that other x-intercept in. Now it's got a way through. Is this anything you're supposed to know ahead of time? No, you're fine. You don't have to know this shit ahead of time. It's just the way it would come out. So again, last thing I'll say about this. I'm sorry, I'm taking too much time up on this. The reason the middle looked like a parabola is because it had no x-intercepts. If I move that wall a little bit down, now it gets an x-intercept to go through, yes? I need you to understand. If I move that wall over here, now it can look like that. And we saw that's exactly what happened. So you cannot, so the great thing about what I just did is you have no reason to know ahead of time exactly what this is going to look like. You have no reason to know. So none of that was supposed to be like, ooh, you're supposed to know. You don't freaking know. You don't know. So you just plot things and kind of let it do its thing. Okay. Maybe. Okay. I don't know if that helped anybody. All right. Thank you for solving. Okay. Anything else? We'll go past that unless you have another question about that. Did I skip over somebody?
No,
I'll come back to you. Wait. Yeah.
6.4.
Anybody had a question related to this? I'm sorry. Yeah. Okay, bounds. All right. So I'll do bounds, and then I'll do 6.4. Okay. And then you have a different question? Okay. On the quiz. Was it on this quiz? Yes. Everybody had a bound question, right? So, again, these are kind of a little weird to try to make up out of nowhere. But if I have a situation where I synthetically divide by something and none of these signs change, well, I gotta be careful, where this is a positive number. So if I divide by a positive number and the answer has all the same sign, there's no sign changes, what does that mean? It's an upper bound. So if I put a positive number in and I get all the same sign answer, right? Maybe it doesn't work, but it still tells me something. It tells me no answer above that can work. That's why if I have a big ass list of things to try, blah, 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 I pick something in the middle. Because if it doesn't work, it might still tell me it's a bound, and then I can throw some other shit out. You're desperately trying to throw shit out of that list. Because the bigger that list is, the longer it might take you to get the answer. I think at this point you guys should agree with me if you've done enough of the homework. Yeah. Okay. So I don't know if this is helping. If you want a specific example, I'm going to have to try to come up with. But if I divide by a negative number and the answer changes signs every step, what does that mean? So this is an upper bound.
It's likely to be a negative number.
Say again.
I could say it's likely to be a negative number.
What does it mean if I divide by a negative number and all the signs change? Lower bound. Meaning you could throw out everything below that. So if my lower bound was -4, I could throw out -5, -6, whatever the hell's below -4, I can just throw it out. It's not going to work.
Would you throw out the negative like 7, -8?
Anything below -4.
So like, you said, oh no, you said -4. Never mind. I thought you said -6.
Okay.
The upper bound is the upper bound, that means everything above 10.
Everything above it won't work. and a lower bound means everything below it won't work. So it's kind of like upper, lower bound just says this is the region where the answers are. Anything outside of that, you know it's not going to work, so don't even try. Again, the book didn't say anything about that, but I still think it's really good, because as you're trying shit, you just might happen to run across. And normally, you know me, I'm going to have divide synthetically by blah, and I'm going to say something like interpret your results, and it's going to be a bound. I'm going to give you a bound. I'm trying to help you cut down on the list. Because the last thing I want to do is give you a problem where it just takes forever, and you're doing the same thing over, and that's just busy work, and that's just taking time. That's just silly. You guys kind of... So if you, on a test, if I give you, let's say Descartes' rule of signs, and I say synthetically divide by this, those two things should help you cut down your list. Okay, maybe. Is that cool? You sure? Okay. And then I had 6, 4.
6, 4, 45, and 48.
Let's see, okay. Okay, so we have to sketch a graph of that. Here's a really, this is on the practice test. Let me bring this over here. Okay, so there's my function, right? So here's a really good thing to do. Can somebody remind me, a little side note here. If I had this function, I know the shape of it, correct? You guys know the shape of it. I just need to know where it starts, right? This is not going to start at 0 anymore. Where's it going to actually start? At 1, yes? So then it's going to be, I can make this better, but it's basically going to be that. That's going to be the answer, correct? Because it shifts. Right. Another way to do this is, what's the domain of this? What must be true about this number to stay real?
It's gotta be positive.
Or equal to 0. So it's got to be not negative, correct?
Oh,
Can somebody tell me anything you know about the graph of a log?
It's inverse.
Of what?
exponential.
Exponential. Cool. So it's an inverse of the exponential. What is true about the shape of the exponential? You guys know the shape is, right? What's the exponential look like? Yeah. Okay, I like it. Like that. Wow. Right? Goes like this, or from your perspective, like that. I think. Yes. Okay. What's kind of weird about that function is the first one we saw is not rational. That has a
Very close to 0.
asymptote. I like it. Are you guys all with? Doesn't it make sense then that if I flip it,
It's gonna be the
make a
same.
log, it's still going to have an asymptote somewhere. So remember, how do I get the graph of an inverse? What do? I take all the x's and y's and I switch it. So there's an asymptote at the x-axis for an exponential. There's an asymptote at the
Why?
y-axis for a logarithm. Yes? So log has this shape because an exponential has this shape. So log has this shape, and this is an asymptote. Let me stop for a minute. So if I just said, sketch a graph of any log, no scale required, this is what you would do. Ta-da! Nowhere near good enough if the whole point is to graph it, but if I just said, sketch a graph, no scale, of a log, bam! Right? Because again, that's the inverse of cha-bow. Let me stop for a minute. So let me see if I can put this all together. From the graph, what is the domain of a regular old log? What's the domain? Can I put 0 in there?
It's gonna be what's the asymptote?
Can I put a 0 in there?
What's the vertical asymptote?
We know what it is.
Zero?
We just said it. So can I put a 0 in there? No. I like it. If I said, what's the log of 0, you'd have to think, what exponent do I raise something to make the output 0? I can't. Negative makes it really small. Positive makes it really big. There's no way to make it 0. That's why there's an asymptote on the exponential. Okay. So normally, for just a logarithm sitting there by itself, the domain is going to be 0 to infinity. So it's got a lot in common with the square root. Normally a square root's got a domain of 0 to infinity, but it can include 0, yes? Because square root is 0, 0. This sucker cannot include 0, because that's where the asymptote is for this poor little dude. Okay. So a way to restate that is, what kind of inputs can a logarithm handle? A non-shifted logarithm. What kind of inputs can it handle? Can it handle negative inputs?
No.
Can it handle a 0 input?
No.
No? So what kind of inputs can it handle?
Positive.
Positive. Kick-ass. So, look at this thing. What kind of inputs can this handle? What must be true about this statement? You just said it.
It has to be positive?
Positive. I love that. How do you write that in Mathish? Greater than 0, solve that shit. It tells you where the asymptote's going to be. Also, look at the x value. Is it positive or negative? Yeah.
Can you explain why you did that?
Right there?
Yeah.
Oh, okay. So again, I know there's an asymptote at 0 because the original asymptote was at the x-axis, right? Y equals 0. So this has got to have an asymptote at x equals 0 because it's the inverse, right? Also, if I ask you what, let me not do that. If I ask you what the log of 0 is, what do I raise 3 to make it 0? There is no number that does that. 3 to a really big negative is small. 3 to a positive is big. There's no way to make it 0. Does that make sense? There's no power I can raise something to and make it become 0. Yes?
Raising it to 0 makes it 1, right?
Yeah. And raising it to -1 over a trillion just makes it really tiny. It doesn't make it 0. Yeah? Okay. So the same way, if I ask you what's the domain of this function, if I ask you what's the domain of this, what's got to be true about the inside? Greater than or equal to 0. And then you solve it. The logarithm is sort of like a radical, but it's worse. It can't even handle if the inside is 0. There's an asymptote there. So how do I figure out the domain of a logarithm? The inside's got to be positive, greater than 0.
Okay, so I know since it's a common log that the base is 10.
Sure, that doesn't.
But
Not yet.
how do I know what the amplitude of it is so I know whether
No
it's like
amplitude.
this
No
or this?
amplitude for a logarithm. Yeah. I'm not sure. There's no.
Well,
It goes to
like
infinity.
it's the curvature. of
Oh,
it.
okay, sure.
You know what I'm saying? It's like, it could be like this, it could be like this. How do I know where that point is?
All right, we'll get there.
Wait, so that's the 6 minus 3x in the logarithm, that's the asymptote, which is the vertical, or the...
It's related to where the asymptote is. So for a regular old log, log base p of x, the asymptote is at 0, right? That's the vertical asymptote.
Okay.
And if I know how this has been shifted around, I could figure out where this guy's asymptote is. The shortcut to do that is just to take this inside and say it's got to be positive.
So the inside is trying to find a vertical asymptote.
Yeah, it's sort of like parabola. Y equals x squared. Where's the vertex for y equals x squared? Where's the vertex? Y equals x squared. Where's the vertex? Y equals x squared. Where's the vertex?
0,
0, 0. Beautiful. If I look at the shifted form of it, can't I tell where the vertex kind of moved to? Right? If I look at x minus 2 squared plus 3, I can just look at it and tell where the vertex is, 2, 3. This kind of does the same thing, except I could do this to get a little bit more specific. If I solve this, I'm going to get the domain of this, which is going to tell me which way is this thing going to go. So if I solve this, what do I get? If I do this, divide by -3, I get that. Yes?
Those signs, you switched it when you divided, right?
Of course, definitely. Because when I divide by negative, I got to switch the sign, right?
Divide or multiply, right?
Divide or multiply by negative. Yeah. So that's going to be where what is?
The vertical asymptote.
The vertical asymptote. The x's have to be less than 2, so I got to put a wall at 2. And this function is a little weird because it doesn't exist at all on the other side of it, right? So now I know there's going to be a asymptote here, and my function is going to live over here, right? Okay, I like it. Now for me, if I'm going to ask you this kind of question, I'm not going to get too deep into transformations for these. I will ask you a question like, you'll definitely get this on the test. Just like on the practice test. What's the domain of this, right? So now I know it's going to open this way because it's a negative x, and I know it's going to have an asymptote. So it's going to look like this, and then I would just let you plot a couple points. Now that you know which way it's going to open, where the asymptote is. Okay. I don't want to spend all day on this problem though. The questions I would ask you related to this are, what's the domain of this? It's just like a square root, except it's not allowed to be 0. It's a little bit more restrictive. So you can always just do this, right? So anytime I ask you a domain question, if I said, what's the domain of this? How would you do that? What must be true about the inside? Inside must be at least 0. Okay, so then inside is 2x minus 5, at least 0. And then you solve. That's the domain. How do you figure out the domain of this guy? The bottom can't be,
-2.
Can't be 0.
you told me the exact opposite of the answer. So the bottom can't be 0, so x cannot be -2.
Minus-
Do you guys understand? So I don't care what function it is. If you can say in English what cannot happen. So if I had this function, what must be true for this to work? The inside's got to be greater than 0. Solve, you'll know your domain. Okay. That's what I want you to focus on in that problem. I'm not too concerned about applying transformations to logarithms because we really don't spend the most time on logarithmic graphs. So that problem, don't worry about applying all the transformations. Figure out what we just did. Where's the asymptote? And then plug some points in to figure out where the hell it is. That's perfectly fine.
I don't think it asked that.
I know, that's what I'm telling you to do.
Oh.
We don't spend enough time on logarithmic graphs to get that specific with it.
What about 48?
Same section?
Yeah.
Yeah, sorry.
Did you want us to write the domain as 2 to infinity?
Oh, I believe I've said this before. I'm okay if you just stop with the inequality, unless I ask for interval notation. But yeah, it would be 2 to infinity. I don't know which one we were just doing. That one. It would be negative infinity to 2 for this, the one we did.
Okay.
Yeah. 48?
Yeah.
Oh, yeah, okay. This is, yeah. Something you can tell very easily, doesn't this have the right shape for a logarithm?
Yeah.
Right, a logarithm looks like this. So that's a logarithm that's just been moved around. Do you guys agree? Can you guys tell where the vertical asymptote has gotten to?
Probably around -2.
-2, yeah. Yeah, right, they made that pretty clear, yeah. That's where the vertical asymptote is. Which means that it shifted back 2, right? So I'd expect there to be an x plus 2 inside of the logarithm. Does that make sense?
Yeah.
This thing did what to that shape?
It's cattywampus.
Sure. Did you guys see what it did? If I just take that shape and do one thing to it, it'll look like this shape. If I just turn it over, yes? If I just reflect it, yes? If I turn this over, it will look like this. Do you guys agree?
Oh, cross.
That's
the
going up,
x-axis.
that's going down. That's going that way, that's going that way, yeah. Okay, okay. So there's gonna be a negative x inside of it. Yeah. Okay. So if you're only having trouble on the logarithmic shift questions, I'm fine. We're not gonna get that detailed with logarithms. I just kind of threw these at you just to see if you could tell. Remember, I don't care what the function is, shifts work exactly the same way. If I put an x plus 1 in any function in the universe, it's gonna go back 1. That's the beautiful thing about transformations. They don't care what function they're in, they do the same thing. Okay, so I'm not overly concerned if you can't get this exact answer, but at least you can tell it's been reflected, correct? Yeah, okay. It's been shifted. Where's the vertical asymptote now? -4, so probably inside of the logarithm is gonna be a x plus 4, right? So let me see. So watch this. It's going to be inside the log. There's going to be an x plus 4, but also hasn't it been reflected?
Across the x-axis.
Yeah.
So it's.
See the reflection
Yeah.
and the shift back. Yes.
Right.
And then you'd have to worry about if it's been moved up and down, and that one's a little bit freakier to tell.
Isn't the x-axis like before the law?
Say again. Oh yeah. I don't know why I put it in there. I'm thinking about this guy. Okay. There. So that's an up and down shift, reflection. It's been moved back 4, reflected around the x-axis. I love it. And again, to figure out if it's been moved up or down, you have to kind of like undo these shifts to tell where it would be. I'm not going to worry about that. We don't have enough time to look at the logarithmic graphs that specifically. Okay. But at least you can pick out those 2 shifts pretty easily. Okay, maybe. Okay, enough of that problem. Anything else from practice test, quiz? Yeah. Oh, slant. Okay. Let's look at this one, because I actually left this one to do with you guys. Number 8. I did it on the paper, but I didn't do this part. Oh, shit. You can't see what I'm doing. So what would I do with this to figure out the slant asymptote? And why is there a slant asymptote? First off, I kind of gave away the game, but why is there a slant asymptote? Top degree is bigger than the bottom.
Well,
I like it. So it's going to go to infinity. It just goes to infinity in a very prescribed way. Yeah.
you would long divide.
Yeah, totally. Why can't I use synthetic division?
Because
The
the top isn't a second degree.
No, the bottom is not a first degree.
Oh,
Yeah. I like it. So I will do this. You can't escape long division. So just to cut to the chase, if you long divide, you will get this. So my slant asymptote will be this. Now, can somebody remind me why? All right, so just to cut to the chase, if you do long division, I'll get this remainder term. Somebody remind me, horizontal asymptotes are what happens when what? Horizontal asymptotes are all about when the input gets
Very big,
very big.
not small.
The remainder, does everybody agree with me? The remainder is always going to be top degree smaller than the bottom, because that's when I know I'm done long dividing. And what situation is that if I'm letting x get big? What's the remainder always going to do?
Very small.
So it's going to go to 0.
Yeah.
That's why this piece, the whole number part, do you see how this is like a mixed number? And this is the whole number part, that is the slant asymptote. So, if I had my calculator, where are you? There you are. It's like freaking Mary Poppins bag, pulling a coat rack. Okay. Did I already put this in here? No, that's something else. So if I put this thing into my graphing calculator, I want to show you a couple things. Okay, that looks good. So if I graph this right now, I have no idea what my scale is. Okay. And I want to show you guys something. Do you see this part here? Do you see how it becomes kind of almost linear already? So if I also graph in here 4x minus 6, and mine is nice, it'll be a different color. Ooh. Do you see how it is? If I zoomed out a bit, I could see it getting closer to that line, right? Here's the problem. Does the other side of this look like it's approaching this side? No, because of this. There's a whole other part of this function way the shit down there. So let me show you something kind of cool. We haven't really used the table too much, but if I go to the table, well shit. If I change table set to auto, so it's going to automatically create the table. And I don't know why I'm stepping by such a weird thing. I can kind of start to follow this backwards and see where my function is. I need you to see this. This is using the table to figure out how much to pull back. I need to change I need to pull back so I can see more of the function, right? Where is my function in the negatives? Where is it? What's the outputs way down here? What's the outputs? At -3, it's at -88. Can you guys see that? Maybe it's too tiny, I don't know. You guys with me? So what do I want to make my y minimum then? So I can see that. So again, if we go to the table, it's just my normal XY table. On the negative side of things, my outputs seem to be way the shit down around -30, -40, and -80. Yes? So I want to make my y min, let's make it -100. And now I can see the other side of this thing. There's the other piece of the function that I couldn't see before because I was only looking down in -10. Now I can see both sides. Now let me make this look a little better because now it looks really funky. But if I make my y max 100 also, now it's going to be a little bit easier to see. There's the slant asymptote. And sure enough, in both directions, it's getting really close to the slant asymptote. Let me stop for a minute. Maybe. The table is an awesome tool. It'll tell you where the outputs are so you can make your y min, y max appropriate so you can see them. If you have outputs around 200 and you're looking up to 10, make that sucker 300 so then you can make sure to see that shit. Yes? You follow. Do you understand? So the whole thing, we've done the window before. The table kind of gives me an idea of what to make my window so I can see some stuff going on. Another thing you could do, go back to Zoom 6. You could always try this. Sometimes this thing doesn't work that well. But I'll try. Let's see what it does. There's one called Zoom Fit. And what this tries to do is it just doesn't work well. Oh, no. Zoom Fit sometimes does well, but it's the calculator trying to assume what we want to see. And the calculator sometimes is really wrong because, it's just a poor little calculator. All right, so Zoom Fit does not always work. Okay. But the table, and then you adjust your window so you can see up and down far enough. That's a good combination. All right, enough of that. Who else had a question that I haven't answered yet? Yeah.
5.6, number 55.
55, 60?
Yes, 5.6 number 55.
55, okay. Oh, yeah, okay. Alright, so let's see. 55 says there is a vertical asymptote at -1, x equal -1. So what do I know already about my function?
That would be the x plus what, the bottom is x plus one. or-
Yeah, there's gotta be on the bottom, there's gotta be an x plus 1, is that cool?
Okay,
Yeah.
yeah.
Because that's where vertical asymptotes come from. So what must have been on the bottom for there to be a vertical asymptote at -1, x plus 1. There's a double zero at x equals 2.
Means your
That means there's
multiplicity is
two. there's
Yeah, so where would 2 have come from?
X,
Uh,
x
X
minus two
minus two.
squared.
And it's got a double zero
Squared.
squared.
Now the y.
And the only piece that's left is,
The line.
if I multiply this thing by some numbers, does that change where the 0 is? Nope, it's still 2, right? Does it change the vertical asymptote?
Yeah.
No, it doesn't change the vertical asymptote. If I multiply by a number, isn't that still -1?
Yeah.
Isn't that still 2?
Yeah.
So, but that number is what's gonna make the y-intercept work.
Yeah. I put a 2 at the bottom, 2 out of x plus 1.
Well, I don't know, alright. So what's supposed to happen when I put a 0 into this? What's supposed to happen?
Well, it says the X.
The answer is supposed to be
4.
2. The answer is supposed to be 2, yes? That's what this says. When you put a 0 in, the answer is supposed to be 2. Now I can figure out what that number is that makes that happen. Because right now, the y-intercept is 4. So one way to do it is to put an a in here, and then you got 4a equals 2. So you know a is 1/2.
That could be like 1/2.
Yeah.
Or the way I do it is, right now, it would be 4.
Yeah.
And I want it to be 2, so of course I'm going to cut it in half. So either way you do it, you get that there's got to be a 1/2 there. So now you put a 1/2 there, you're golden. Or a 2 on the bottom, you're golden. So the A way to do it is a more direct way. Or you can just kind of go, let me adjust what it is to what it's supposed to be. You can do it either way. Okay. Yes, don't. People are all doing something. Okay, yes.
84, same section.
Okay. Oh yeah. Okay. Let's do this one again. Okay. So one really good skill to have is how to draw a 3D box, right? So the easiest way to draw a 3D box is to just draw 2 boxes and then connect the corners. Yes? Has anybody ever seen that? Right? Okay. I don't like that because then you get all these internal lines, so I just do this. Okay. It's a little bit cleaner. And then if I want to, I can put the internal lines. Yeehaw. What's got to be true about the base on this thing? What's true about, the only thing it tells me about the base?
It's square.
Square. So, x is the length, so what's this got to be here?
X.
X, because it's square.
Yep.
Can I make this x also?
Yep.
Why can't I not make that x also?
Because.
Does the height have to be the same
No.
as these? No. So what am I going to call that? I would call it h. You can call it y if you want to. Right? You can leave your friends behind.
Because 108 is not a perfect cube,
Yeah, it doesn't matter.
but that's why it can't be X.
So they tell me. No, it could be x. It just could have very weird side lengths. Yes? Cube root of 108 is a real number. You with me?
Okay, it's a real number. but-
Yep. It doesn't have to be integer lengths. So it could be a cube. We don't know.
All I'm saying is not a perfect cube.
So they tell me the volume is 108. So what's the formula for the volume of this box?
Length times
Yeah.
height.
Length times width times height. And I know that's 108. And what are they asking me for? What are they asking me to do, to find?
Asking for the dimensions.
That do what? Minimize surface area. So they tell me something about the volume, they ask me about the surface area. There's no surface area formula to memorize. It's just like perimeter. You don't memorize perimeter formulas, you just add up all the side lengths. You don't memorize surface area formulas, you just add up all the sides. Notice it's open, right? That means it does not have a top. So what's the area of the bottom?
Square.
X squared. And what's the area of one of the sides? And how many of those are there? 4. So there's that formula, right? They want us to minimize this. So what do I do now? Besides run away screaming, hide under my bed. What do I do? Yeah, I got something they told me, and I have something they asked me, and there's too much shit here. So what can I do? Say again. You know what H is, right? Is that what you said?
Just kind of.
You can solve this thing for either letter, but I'm going to solve it for H because the X would involve the square root. Can you solve this for H? What would you do to get the H by itself?
Divide by.
Divide by X squared. Now I know what H is. I can put this wherever I see an H. Let me stop for a minute. I don't know if you guys have picked up on this. Like every time I do a problem like this, there's something they tell me and something they ask me. I write a formula for each, and then I use what they tell me to help with what they ask me. Now, this thing is gross. Do you guys agree with me?
Yeah.
1x cancels there or whatever, right? Just to point out, use a freaking calculator, right? So you're going to graph the results, you're going to graph this thing in your calculator, and you're going to find there's going to be a place that's a minimum. So you're going to find the minimum function in the calculator to find that. Anything that's not parabolic. If this is a parabola, we could find the minimum by hand. I wouldn't need a calculator, right? Negative b over 2a. That's how I find the minimum parabola. Is that a parabola? Damn it, I need a calculator. Calculus, you won't need a calculator, but we're not there yet. Maybe. Anna, you okay? Okay. Are there other questions about that problem? Okay. You gotta look at me very expectantly, but if there's no questions, I don't know where things went wrong. Okay. Anything else then? If there's no more questions, yeah.
Can you go over like the best principle of signs and like the possible attributes?
Oh yeah. All right. So if I'm given a function, how do I investigate the possible real positive roots?
Use how many times?
Number of possible real.
How many
Positive
sign changes
roots.
it has?
Say again?
How many sign changes?
Yep, sign changes in the given function, right? So we'll do a specific example in a minute, but how do I investigate the number of possible negative real roots? I look at f of negative x, and again, I look at the sign changes. And we talked a little bit about why this makes sense. This is actually directly related to bounds, for example. So if I have this problem here, how many sign changes do we see? So again, there's still a little bit of confusion. Starts off positive, correct? Did it change signs to the next term? Nope. Did it change signs to the next term? Yes, there's one. Did it change signs here? Nope. Did it change signs here? Yes, there's 2. Did it change signs here?
Yes.
There's 3. So what does that mean? 3 or 1 possible, let's see, positive real root. So you could have 3 positive real roots or 1 positive real root. So you're guaranteed to get 1 positive real root. If I look at f of negative x, it's the same thing as throwing a negative number in. What's the shortcut for that?
I look at the odd.
All the odd ones are going to change sign.
Right.
So that's going to become negative, that's going to stay the same sign. That's going to become positive, that's going to stay the same sign. That's going to become negative, that's going to stay the same sign. Why does that work? Because when I throw a negative in, the even are going to kill it, and the odds are going to let it live. That's it. Now I see 1, 2, and that's it. So how many negative real roots are there? 2 or 0 negative real roots. Now in this case, does Descartes really help me that much? No, but me, I would start with the positive roots because I'm guaranteed one of them is going to work. There could be 0 negatives, so I'm not going to touch it. And plus the positive, I could have 3 of them work. So there's a good chance I'll get something quicker if I do a positive root first. You guys kind of, if I have a big ass list of things to try, I'm going to try some of the positive ones because I'm guaranteed to get an answer. Yeah. 1A? This guy. Yeah, this is the kind of question I'm going to ask you. Right? So, how did we just say we could do this? Oh. Yeah, the logarithm cannot handle negative inputs, and it can't handle a 0 input. It can only handle it if the input is positive. So 5 minus x has to be greater than 0, and then you just solve that. Right? The beautiful thing about anytime I ask you a question about the domain of a function I give you, can you just say in English either what must happen or what can't happen? And then write that in Mathish. Here, the inside must be positive. Inside, positive. Solve that, you're done. Yes?
So what's the range?
Yeah, here's the beautiful thing about this. Can anyone show me a logarithm function in the air? What do they look like? What's the basic form of a logarithm? Yeah, starts from negative infinity, goes up to positive infinity. So the range for almost any log, especially all the logs we're going to look at, the range is going to be all real numbers. You guys semi with me? Exponentials. Their range is going to be from the asymptote up forever unless they've been flipped around, right? So logarithms, their domain is restricted, but the range is all real numbers. Exponentials, their range is restricted, but their domain is all real numbers. And of course it makes sense because they're inverses of each other. So this is going to be the domain. Is that cool? And the range will just be all real numbers. Or you can say all real numbers, either way. Exponentials are the other way around. I know exponentials look like this, so it's all about, the domain is always going to be all real numbers, unless something really, really, really weird happened. And we're not going to do anything really, really, really weird to them. It's the range that's limited, yeah? It's got a floor or a ceiling if it's been flipped around. So normally the range for a nice, normal, undone, anything is going to be 0 to infinity, because it's going to have a floor at 0 and go to infinity. So what's the most important thing here is, where did the asymptote go? Can anyone tell me, for that function specifically, where did the asymptote go?
0.
It went
Up to.
It went up 2. So now what's my range going to be? My floor is 2, so my range is going to be, my floor has gone up 2. So now my range is gonna be,
From negative infinity.
no. It's just gone up 2. So now my range is gonna be
Oh,
To
2 to infinity, yeah. Because I didn't reflect this over the x-axis, right? Okay, okay. So here, let me give you this. Let me give you the answer key. So you got a little bit to look it over. Sure. All right. Yeah.
For two B with log base 5, when we're graphing, do we just do the general shape? Or how do we include the 5 in the graph?
Oh, yeah, how specific was I here? Okay. Alright, so for a logarithm, for just a nice log, let's see if you guys know enough about this. So we know there's an asymptote where? For just an unshifted log. Where's there an asymptote? For an unshifted logarithm, just this poor little log right there, where's the asymptote?
0.
0, okay, at y equals 0. Okay. For any unshifted logarithm, what do I get when I put a 1 in? What's log base 5 of 1? 0. So 1, 0 is going to be a point. What do I get when I put a 5 in? What's log base 5 of 5? 1. So I got my kind of like anchor points. One anchor point is the asymptote, and then I've got 1, 0, and then I got the base 1. And I just got to move those points around, right? So how does any of this stuff work for transformations? Give yourself some anchor points, and then move those suckers around. That's how that always works, right? So you can always do 1, 0, because log of 1 is always 0. And you can always do base 1. Log base 5 of 5 is 1, log base 7 of 7 is 1, so forth, right? And then you got points to move around. How am I going to move them around? What are the transformations here? Don't even look at the answer key, just look at this.
-1.
Well, maybe it's going to come back. Be more specific.
Move over left 1.
Left 1. Down 1. 11. So where's the asymptote going to go? It's currently there at the y-axis. Where's it going to move? It's going to move to -1. Yeah, it's going to go back 1. It goes up and down forever. So if I move it up and down, it's like it didn't change. Only left and right's going to matter. Okay, maybe. Yes?
I have a question about 5D. What is IN?
Oh, yeah.
Yeah, that was a
So in the homework, hopefully you've hit this. Let's see. So it's just the symbol we give. Real quick, let me build up to it a little bit. Can anyone tell me the inverse function for 3 to the x? What's the inverse of an exponential?
logarithm.
Logarithm. So what's the inverse of 3 to the x?
Log 3 is that?
Log base 3 of x. We know this. We know logarithms are inverses. We constructed the logarithm function from the idea of inverse. So we kind of made it exist. It's the inverse of 3 to the x, for example, in this case. So if I have e to the x, I'm going to write this. This is the only time I'm ever going to write this for you, okay? It hurts me to do this a little bit. So the inverse should be log base. You can do it. What's the base? E. So log base E equals x.
That's ln.
We have chosen to give this guy its own little expression. So ln is the same thing as log with a base of e. It's called the natural log, and the reason, why do we use square roots the most? Because they just make sense to use the most. Logarithms, the natural log, e is kind of like models how things grow, so natural log is its own thing. It's kind of like used in figuring out certain aspects of something that has natural growth. So I use a natural, and so we call it a natural log. It's related to natural processes. So that's why it's just another symbol instead of log base e. That's all it is. So, for example, real quick, can anyone tell me very quickly what log base 3 of 3 to the m? You could do this.
Oh, that's
Yeah, what's log base 3 and 3 to a power? They are what kind of functions?
Inverse.
Inverses. So what do they do to each other?
Cancel out.
Cancel. So what's the answer?
M.
M. Beautiful. Now what's natural log e to the w?
0.
W. Again, natural log is just log base e. Logs are inverses of exponentials. They will kill each other when you put one of them into the other one. One last thing. What is 10 to the log b? Yeah, this is understood to be base 10.
Yeah.
They're inverses. Answer is B. All right.
What about 5C?
Oh, shoot. There it is. There's a blank there. Oh, so I gave 2 ways to do this on the answer key. The answer, I don't know what the answer is. How can I rewrite this? How do I rewrite this? 16 to the
What?
to the x equals 1/8. What base are 16 and 1/8 both related to? What base are they both built off of? 2. I can do 2 to a power to make 8 and 16, correct? 16 is 2 to the what power? Stop it. 16 is 2 to the what power? 4. 8 is 2 to the what power?
1/3.
No. 8 is 2 to the what power?
-3.
Third. So 1/8 is 2 to the
Negative.
-3rd. Okay, there you go. The only way this could be true is if what's true about these powers. 2 to something equals 2 to something else. They actually have to be, the only way they could be equal is if 4x and -3 are equal. I love it. Does that make sense? If I say 2 to the 7 equals 2 to something, that something's got to be 7. That's the only way they could be equal. Does that make any sense, guys? The only way 2 to some power can equal 2 to some other power is if these are actually the same power. That's the only way they could be the same. So then I have 4x equals -3, and then I divide, and I'm done. That is one way you can always do a problem that's a little freakier like this. Can everybody see every number involved in this is based on 2? Can you see that? If I would have put 27 and 9, I would have made it based on 3. And I could do exactly the same thing I just did here. On the answer key, I gave kind of a different way to look at it that's less mathy.
On the answer key, it's 3/4.
Instead of negative equals.
Did I lose my negative?
Yeah.
Oh, yeah, I did.
Negative.
Yeah. My poor little negative dude got lost. Both times. Yeah, okay. Cool. Still averaging about 97. I love you guys. I understand. I'm the guy that gets to mark through all your mistakes. So if I make a mistake, you're like, yeah. But, you know, we're all human. All right, guys.
That's tomorrow.
You can always obviously. You can always email me. I can try to get back to you if you have questions. Come in early tomorrow if you have questions. Oh, you did email me. Yeah.
Oh my gosh.
Email, did you just email me or have you emailed? Email me. I'll tell you what the room is, right? Thank you.
What's the due for the test again?
6-4, 3-6.
No, I'm not.
Oh, okay, so you didn't realize that you could throw out some stuff, right? So here's the thing, 10 is enough. From the work you've done, you still have negative possibilities, right? So you should not throw out negative 12, negative 15, negative 20. You see what I mean? Does that make sense? So they should still be. So you gotta be careful, if the plus or minus is still here, you found one down, you could throw out, I could throw out all the positive things bigger than 10, but the negative things should still be there. Beautiful. Exactly. So then it would have been, then this would have been, that would have been right. Because the only things that are possible. But do you understand that I'm grading based on what you've done?
Yeah.
And your negatives could still be there. But when you make corrections, just don't write the plus or minus. And,
That's what I mean.
For this one, is there supposed to be a -8 there?
-8? Where?
Or -8?
Oh, there is supposed to be a -8 there.
That was, I did it a bunch of times. I can-
Yeah, that's, you're right.
Thank you.
Sure.
Sorry.
Oh, yeah.
Thank you so much.
Sure.
My kids,
Sorry?
for my kids, so.
Oh, you,
Yeah,
oh,
yeah.
you're what now? Sorry? You're
Your, the kids are 3? maybe?
the key?
Yeah,
The answer key.
last
That is the
time,
answer
yeah,
key.
last
Right.
time. Kids,
Last time.
yeah. I didn't get my keys. So,
You're. Oh. I gave you back what I had. Wait a minute. Oh, here you go. Okay. Your quiz.
Oh, thank you so much.
Sure, sure.
So I'm gonna be out of country I'm flying back on the 1st. I know we have to start class again on the 1st of April, right?
Yeah, right after spring
Yeah,
break.
because that's Sunday's the 31st.
Okay.
So I'm flying back. I'll be back by Tuesday the next day, so I'll just be missing 2
All right.
classes.
I'm gonna forget everything you're telling me right now.
I know.
So if it's important, you gotta keep it.
Oh no, I'm just
Yeah.
asking if there's gonna be a quiz or a test.
No, I never do that the day after spring break.
Or that's,
That's more evil than I'm capable of.
Alright.
Yeah.
Alright, well, I'll check up. It's not gonna, I'll catch up.
Okay. Yeah.
I'm just letting you know, I'll be
If
gone.
you email me, I can send you whatever you're talking about. Blah blah blah.
Yeah, I won't be there the first 2 days after spring break.
Okay.